So this video will go over section 11 and 12 of chapter 7. Section 11 on energy and phase changes. Let's look at the phase changes that converts a solid to a liquid. So here we have solid water on the right and liquid water on the left. Sorry, it's the reverse. Solid water on the left and liquid water on the right. And so you can see that it's both showing packed molecules of water, but on the left you have the solid where you see some pattern, it's organized, it's not random. And on the right, for the liquid state, you see how the molecules are randomly packed together. There is no order. So the phase change that changes the solid to liquid is called the melting. Melting is endothermic. Remember, endothermic means it takes the energy inside. Endo refers to inside. Thermic refers to thermal energy. And so the solid will take the energy, thermal energy inside and become liquid water. So heat is absorbed by the solid. The phase change that comes from a liquid water to solid water is called freezing, and because it's the opposite process of melting, and melting was endothermic, so freezing is exothermic, whereas the opposite of the other phase change. So freezing is exothermic, which means when you go from a liquid phase to a solid phase, energy is released to the outside. Exothermic means the thermal energy is exiting the system you're looking at. And so a phase change converts one state to another, and energy is absorbed when a more organized state is converted to a less organized state. And here, the more organized state is the solid state, and the less organized state is the liquid state. And so energy is absorbed when you need to break some of the attractions and become a less organized state. And that's the melting that is endothermic here, for example. And so energy is released when a less organized state is converted to a more organized state. And so now if we look at the two phase changes between liquid water and gaseous water, when you go from the liquid water to gaseous water, it's called vaporization or evaporation. It means the same thing. And these are endothermic processes. Vaporization is endothermic, which means the liquid water will need to absorb energy to become gaseous. And that's because water is more organized than the gas. Liquid water, I mean. And so the reverse process, which is called condensation, which converts a gas into a liquid, will be exothermic. Exothermic means the energy is released to the surrounding because you go from a less organized state, which is the gas state, into a more organized state, which is the liquid state here. So when you have opposite phase changes, one is exothermic, the other is necessarily endothermic. Another set of names that you need to remember are sublimation and deposition. And this is when you go directly from a solid state to a gaseous state and vice versa. So on the left side here, we have a solid carbon dioxide, which we are commonly calling dry ice. So you see how the molecules of CO2 are packed together in an orderly fashion. You can see that there is a pattern there. And then when they are in the gaseous phase, they are completely free from each other, flying around. It's very disorganized. And so the phase change that designate the change of a solid to a gas is called sublimation. Sublimation refers to the fact that you go directly from a solid to a gas without going through the liquid phase. And sublimation is endothermic. It requires a lot of energy to go from the solid phase to the gaseous phase, because all these attractions between the molecules in the solid phase, they need to be broken down to come into the gas phase. And the reverse process is called deposition. When you go from a gas to a solid without going through the liquid, it's called deposition. Deposition is endothermic. It releases energy to the outside because you go from a very disorganized state to a very organized state. So it releases a lot of energy to the outside. So this table summarizes those phase changes, and you need to learn the name of the process, you know, melting, freezing, vaporization, condensation, sublimation, and deposition. You need to know what they mean, you know, the phase change they correspond to. And you need to somehow remember that which ones are exothermic and endothermic, and what endothermic and exothermic mean. So, for example, melting is changing from a solid to a liquid, and it's an endothermic process, which means energy is absorbed by the substance. And the opposite process is always, you know, if one process is endothermic, the opposite process is always exothermic. They're always opposite, because if you need energy to be absorbed one way, then you will release energy the other way. So this table summarizes what you need to remember out of this. So section 7.12, we'll go over a heating curve and a cooling curve. So a heating curve shows how a substance temperature changes as heat is added to the substance. So the x-axis here shows how heat is added. So as you go from left to right, we are adding heat. And the y-axis is showing how the temperature here changes for the substance. And because it's a heating curve, we are adding heat, then the temperature will increase gradually. And so from point A to point B, so from point A, you start with the solid. And if you add heat to the solid, you will increase its temperature from A to B. That's going to be just warming up the solid. From B, when you reach the melting point for the solid, and when the solid starts to melt, every heat that is added will be used to break down the attractions between the molecules and change that into a liquid phase. So from B to C, when you are at the melting point, the solid is becoming a liquid. And all the time that you're having this process, the temperature cannot increase because the heat is used solely to change the solid into a liquid. Once all the solid is changed into a liquid, so at point C, the heat that is added can be used again to increase the temperature of the liquid. Now we have only a liquid. And so you see the temperature of the liquid increasing as heat is added until we reach the boiling point, which is at point D. So when you have reached the boiling point of the liquid, it will start changing to a gas. And so all the heat that is added will change the liquid into a gas, and the temperature cannot increase until all the liquid has been changed into a gas. And that's when you reach point E. And so from point E, all the heat that is added will change the gas temperature and increase it. So you see that the temperature increases again from that point. And from point E, what you have is only a gas. And so the temperature of the gas increases as you add heat. And so a cooling curve is when you, instead of adding heat, you are removing heat. So it shows how the substance temperature changes as heat is removed from the substance. So again, the x-axis shows the how the heat is removed, and the y-axis shows the temperature. And so you start with the gas. So, sorry. At point V, we start with the gas, and we remove heat from the gas. So when the gas is when heat is removed from the gas temperature will decrease, right? Until you reach the point W. So temperature of the gas decreases until you reach the boiling point, which actually here would be the condensation point, because we are cooling down. So the gas now will start transforming into a liquid. And this process is called condensation. When the vapor becomes a liquid, we call that condensation. And all the while that the condensation is happening, the temperature cannot change, and we stay at the boiling point, which is the condensation point. And so when we have both gas and liquid, temperature stays until we reach the point where all the gas has been changed into a liquid, and that's point X. So from point X, we only have a liquid now, and the heat removed will only decrease the temperature of the liquid. So we see now the temperature decreasing again from X to Y. Temperature of the liquid decreases as you remove heat. At point Y, we reach the melting point or freezing point of the substance, because here we are cooling down. So you go from a liquid to a solid, and so that's called freezing. And so we have reached the freezing point at point Y. And all the while that the liquid is transforming into a solid, the temperature cannot change, and you stay at the freezing point. So at point Z, all the liquid has been changed into a solid. And when you continue removing heat, now the temperature of the solid is decreasing. So you see the temperature decrease again from Z downward. So notice how this, actually this substance shown here was the molecule of water. You can recognize the H2O model. And you recognize that the boiling point is 100 degrees Celsius here, and the melting point is 0 degrees Celsius. So keep this cooling curve in mind for the next learning check. Use the cooling curve for water to answer each of the following. So water vapor condenses at a temperature of, so water vapor condenses at a temperature of, and that's 100 degrees Celsius, right? When water vapor condenses, it becomes a liquid, right? Condensation is the change of a gas into a liquid. And even though we tend to call this the boiling point, it's also the condensation point. And so vapor water will condense at 100 degrees Celsius, which is the boiling point of water. At a temperature of 0 degrees Celsius, liquid water, what does it do? Freezes, melts, or changes to a gas? So at 0 degrees Celsius, liquid water. So we start with liquid, and it's 0 degrees Celsius. 0 degrees Celsius is the freezing point or melting point of water. And here, because we start with liquid water, so we can call it the freezing point. And it will freeze, right? Become solid. because the 0 degrees Celsius is both the melting point and the boiling point. Sorry, the melting point and the freezing point of water. So when water freezes, heat is removed from water or added to water? So when water freezes, it's the freezing. The phase change is called freezing. Freezing goes from a liquid state to a solid state. Liquid is less organized than the solid. There is more forces of attractions in play in the solid that keep the molecules, in place. And so it stabilizes the substance when you are going from liquid to solid. So energy is removed from water. It's released to the outside, which means it's removed from the water, right? Because freezing is exothermic. So exothermic for water, which means water is exiting thermal energy and leaving it to the outside. So let's do another learning check where we will decide if heat is absorbed or released during the following changes of states. So we have rubbing alcohol evaporating from the skin. You probably have experienced that, and you know how it feels very cool when you do that on your skin. And the rubbing alcohol is just evaporating and so disappearing, right? So it's going from a liquid phase to a gaseous phase. It's evaporation. And evaporation is endothermic. Endothermic means the alcohol will need to absorb heat from the surrounding to be able to go into the gas phase. And so the heat that the rubbing alcohol will take, it will take it from your skin. That's why it feels very cool on your skin, because the alcohol took the heat from your skin and used it to evaporate, to become from liquid to a solid, to a gas, sorry. So heat is absorbed by the alcohol from your skin because evaporation is endothermic. So what happens when frozen food is thawing? So let's say you have frozen food in your freezer, you take it out to thaw it. And so outside the freezer, the temperature is higher, right? The room temperature is warmer than the temperature in the freezer. So the food now can absorb that heat, right? And that will allow it to thaw. So heat will be absorbed by the food. It will be taken from the warmth of the room temperature, and it will absorb it to, go from a solid state to a liquid state. So that's what thawing is about. So heat is absorbed by the food. When water condenses on a window pane, so what happens? So each time when you have these questions, you want to decide, you need to place yourself in the place of the substance that goes through the phase change, right? That's always relative to the substance that goes through the phase change that you want to decide if heat is absorbed or released. Here, water is condensing on a window pane. Condensing means a condensation. Condensation means you go from a gas phase to a liquid phase. And this is a exothermic process. Heat is released into the room because when water as a vapor, so you have some vapor water in the room, and let's say the windows are cold, and so when the water vapor is close to a window, it gets cooled down and it will condense into tiny droplets of water, of liquid water. So the water goes from a gas phase to a liquid phase, which is a more stable state for the substance. And it's more organized. And so the fact that it's more stable means you can release heat to the surrounding. And so heat is released into the room. Because condensation is an exothermic process. Heat is released to the outside. Now, ice depositing on a cold pack that has been taken out of the freezer. So you have a cold pack in the freezer, you take it out, and you see some building up of ice on top of the cold pack. And here, depositing refers to deposition. Deposition is the word to talk about the phase change that goes from gas to a solid directly without going through the liquid phase. So when ice is depositing on the cold pack, it was water vapor first in the room, and by contact of the cold pack that is really cold, it will cool down the vapor so much that it's depositing into ice. So deposition is the process of going from gas to a solid. And so you go from a very disorganized, molecules far from each other, freely moving, to a very compact and organized state. The solid state is very organized. And so this releases a lot of heat to the outside. Deposition is an exothermic process because you go from a gas phase, which is very disorganized, to a very organized state, which is the solid state, where molecules are packed together in an orderly pattern. So heat is released into the room.